In this section, we will learn about the 5 key points of a tangent function and graphing the tangent function. So for a tangent function, the period is pi, which means it takes pi radians to complete one cycle and occurs between negative pi over 2 and pi over 2. So if we were to look at our unit circle, for sine, cosine, tangent, we would go 0, pi over 2, pi, 3 pi over 2, 2 pi for our key points. However, for the tangent function, it's a little bit different. For the tangent function, we start here at negative pi over 2. Remember, this point here is going to be the point 0, negative 1. And then we're going to go to negative 45 degrees, which is going to be negative pi over 4. And then we're going to be at 0 radians. And then we're going to be at 45 degrees, which is pi over 4 radians. And then we're going to end at pi over 2. And that completes, so this part of the unit circle, this completes one period of the tangent function. And once again, this here is going to be negative pi over 4 radians, and this is going to be pi over 4 radians. So let's go through and figure out the value of tangent of x at each of these. So at negative pi over 2, the tangent of negative pi over 2. So if you look at the tangent of negative pi over 2, tangent is always y over x. In this case, y is negative 1, x is 0, so we have an undefined value here. An undefined value means that at negative pi over 2, we are going to have an asymptote, a vertical asymptote. Okay, our next key point is negative pi over 4, which is negative 45 degrees. The ordered pair on the unit circle is going to be radical 2 over 2, comma, negative radical 2 over 2. The x is positive, the y is negative. Now the tangent there is going to be the y value, the numerator of the y value divided by the numerator of the x value. So negative radical 2 over radical 2, that's going to be negative 1. At 0, the order pair on the unit circle is the point 1, comma 0. So if we take the y over x, 0 over 1 is going to be 0. At pi over 4, the order pair is going to be radical 2 over 2, comma radical 2 over 2. Let me fix this real quick. Okay, so at pi over 4 radians, which is 45 degrees, this is pi over 4, the order pair is radical 2 over 2, comma radical 2 over 2. So if we take the y of the the numerator of the y value divided by the numerator of the x value, this will give you 1. And then at pi over 2, this point is 0, 1. If we take y over x, that's 1 over 0, and that's going to be undefined. Which means we have an asymptote at negative pi over 2 and again at pi over 2. At negative pi over 4, we have a value of negative 1. This is negative 1 here. And then at 0, we have a value of 0. And then at pi over 4, we have a value of 1. And our tangent function is going to look something like this. And remember, that pattern keeps repeating. So if we go pi over pi units again, because remember, one cycle is pi units, so that'll be here. We have another asymptote, and then this will be our tangent function, something like this. And so on and so forth. And that pattern will just keep repeating infinitely. So these are the 5 key points for our tangent function. Now, in the general equation, you have y equals to a times tan b times the quantity x minus c plus d. The period is given by pi over b. Notice that it's pi, not 2 pi, because one period of a tangent is pi radians, not 2 pi radians over b. Just like before, b and c affect the x values, a and d affect the y values, and we're going to be using the same steps to graphing as we did previously. So here, the question is, what is a period of the graph of the function y equals to 11x over 3? Now remember that the coefficient of the x is going to be the b value. So I'm going to rewrite this as y equals to tangent of 11 over 3x. So this is going to be the b value. And we know that our period for tangent is going to be pi over b, which is pi over 11 over 3. And we can't divide by a fraction, so we're going to multiply by the reciprocal of the fraction, which is 3 over 11. And then if you take pi times 3 over 11, this is going to give us 3 pi over 11 or 3 over 11 pi, however you want to write it, and that will be the period of the function y equals a tangent of 11x over 3. Next, given the equation y equals to 2 times tangent of 4x plus 12, find the period, the amplitude, and the horizontal shift. Now remember the argument, the x has to have a coefficient of 1. The x has to be by itself. So before we do anything else, we need to factor out a 4. And when you factor out a 4, you're essentially dividing each of these terms by 4. So 4x divided by 4 is x, 12 divided by 4 is 3. Now the amplitude is going to be the absolute value of a, and the absolute value of 2 is simply 2. The period is going to be 2 pi over b. I'm sorry, not 2 pi. I made a mistake. For tangent, it should be pi. So it's going to be pi over b. In this case, the b value is 4. So our period is going to be pi over 4. And the horizontal shift, so remember that when we have horizontal shift is also called a phase shift. So when we have x plus c, we move to the left. When you have x minus c, we move to the right. In this case, if you set x plus 3 equal to 0, we're going to get x equal to negative 3. So we're going to be shifting negative 3 units to the left. Or we can say 3 units to the left. The phase shift is negative 3. So I should say negative 3 units, or that's the same thing as saying 3 units to the left. Because negative 3 units to the left would be redundant, so you could say negative 3 units or 3 units to the left. All right, lastly, let's go ahead and graph this. So our a value is equal to 2, which means that each y value is multiplied by 2. We have, if we set x minus pi over 4 equal to 0, we get x equals to pi over 4. So we have a phase shift at pi over 4 units, which means that each x value is increased by pi over 4 units. So our job is to find the new x values and the new y values. So let's start with the x values because they're a little bit difficult, more difficult at least. For the first x value, our first key point is negative pi over 2. And to that, we're going to increase it by pi over 4 because we have a phase shift to the right of pi over 4 units. The common denominator here is going to be 4. So I'm going to multiply this first fraction by 2 in order to get a denominator of 4. So this gives us negative 2 pi plus pi over 4, and that'll be negative pi over 4. So my first new x value is going to be negative pi over 4. My next x value, we have negative pi over 4 plus pi over 4. Luckily, this is just 0. We don't have to get a common denominator. Our next x value is 0. If I have 0 plus pi over 4, this just gives me pi over 4. My next x value is going to be pi over 4 plus pi over 4. So I take my key point and I add pi over 4 to it. This gives me 2 pi over 4, which is going to be pi over 2. And then lastly, I have pi over 2, and I'm going to increase it by pi over 4. So if I get a common denominator, which means that I multiplied both of these by 2, then I get 2 pi over 4 plus pi over 4, and this gives me 3 pi over 4. Those are my x values. Now for y equals tangent of x, the original 5 y values, this is going to be undefined, -1, 0, 1, and again undefined. So the undefined, you can't, there's nothing there, so these are both going to be undefined. -1, we're going to multiply each y value by 2, so -1 times 2 is -2, 0 times 2 is 0, and 1 times 2 is 2. So let's graph this. We have negative pi over 4, and there is an asymptote there, a vertical asymptote. Then my new x value is 0, and the corresponding y value is -2. For pi over 4, my x value is 0. And then the next one is pi over 2. My x value, or my y value, sorry, is 2. My y value, not x value. And then finally, at 3 pi over 4, I have a vertical asymptote. So my graph of tangent is going to look like this. Remember, this is the basic shape of that graph, just like curvy shape. And that's it.